Yeah, let us look at the example of abstract classes. Already we have used this example for polymorphism in the previous video. Now here there is an argument that I have a class Innova that really exists and a class called Swift, though Swift car also exists in real world, but a car class is a virtual one, it's logical one. So that is the reason we have to make a function also as virtual. So then the question is, why do you define this function? So if you don't define this function, then you should make it as 0. Then this will be called as a pure virtual function. And when a class is having a pure virtual function, then it is called as an abstract class. Let me undo this one and show you. Here inside the main function, I can create an object of car class. This is allowed. If I change this function to a pure virtual function, then the class becomes abstract and I cannot create an object of car class. See, a variable type car is an abstract class, so I cannot create an object of abstract class. But I can have a pointer of car class. So the purpose of this pure virtual function is to force the child classes to override that function. And if they don't override, if I make this as a comment, then Innova also becomes a abstract class. See, for Innova also I cannot create an object, allocating an object of abstract class. So Innova also became abstract. So if a class is inheriting from abstract class, it will also become abstract and it will become concrete if you override pure virtual function. Pure virtual functions are used for achieving generalization and achieving polymorphism. So we define generalized classes with the functions which are undefined and which are made as pure virtual, and the reason is we want to achieve polymorphism. I'll take another example and show you about an abstract class. Yeah, let us write a base class having public functions, that is void fun1, and let us display cout fun1 from base and L. Then I will write one more function, that is fun2, and this function cout fun2 from base, and also I'll give and L, and here the class ends. So I have a base class, then I will define a derived class inheriting publicly from base class. So this derived class is inheriting from base class, so it is getting all the features of base class. So here you can see that the purpose of base class is for reusability. Child class can or derived class can get the features of base class. If I create an object of derived class and call the function, I can call all the function fun1 as well as d dot. I can also call fun2. Yeah, both are the functions of base class that are called. So the purpose of this base class is reusability and the child class can get the features. Now I will override one function. I will say void fun2. I will override this function and I will display this is fun2 of derived class, and also I will say and L. Now what has happened? The function fun2 is overridden by derived class. So if I run this, let us see what messages I get. Fun1 of base class and fun2 of derived class. So this means that derived class doesn't want that function, so it has redefined its own version of function. Now what is the use of base class? This base class is having two purposes. One is reusability of function1 in child class, and other one is achieving polymorphism. Overriding helps in achieving polymorphism. So now this type of base class having two reasons, that is reusability and polymorphism. Now when I know that the derived classes are supposed to override this function, so I can make it as virtual. Now we can perfectly achieve polymorphism by taking a base class pointer and derived class object. Now, next argument. When you have made this class function as virtual, then why don't you make it as pure virtual function? So this shows that the purpose of this function is it must be overridden by derived class. So it is compulsory or mandatory for derived class to override this function. Otherwise, derived class also becomes a abstract class. Now base class became an abstract class having pure virtual function. But one thing to observe is one of the function is concrete and other function is abstract, that is virtual. So this base class is having two reasons, that is reusability as well as achieving polymorphism. If I make this function also as virtual and make it as initialize with a 0, then both the functions are virtual. Now the purpose of this base class is only to achieve polymorphism, and in the derived class I must override all those functions. See here, I cannot create an object of derived class because derived class became abstract and it is not overriding fun1 function. So I must override other function also, that is function fun1, and I'll just write down dummy function. Now this message is gone, error message is gone. So these type of base classes are whole and soul. The purpose of these base classes is to achieve polymorphism. This becomes an example of generalization, and the purpose is achieving polymorphism. Now such classes which are having all virtual functions can be called as interfaces. We can call them as interfaces, though there is nothing like interface in C++, because the purpose of this class is to achieve polymorphism. So that's all about the abstract classes. So abstract classes can have two reasons. They can be helpful in reusability as well as achieving polymorphism. If it is fully for polymorphism, then such an abstract class we can call it as interface. So you can try this program